What is up, guys? Fahir here from awesomedudes.com. In the previous video, we have animated our player, and now let's make him move and of course animate him while he is moving. Now, before we actually do that, because we're gonna apply gravity on our player, we want to have a ground where the player can stand on. Now, of course, we can do that simply by right-clicking here in Hierarchy, create an empty game object, and add component box collider 2D. As you can see, this right here, this box, it's a collider. We will talk about them in a second, don't worry. And I can resize this collider, so I can resize it like this. And bam, this is a ground where the player can stand on, but visually, it's nothing there. It's not visible because it only contains a collider, which is not visible in our game preview. So because of that, we are gonna go and use some of our sprites, and along that way, we will explain some other things. If we go in our sprites, and then in the tile set folder, you see we have 6 tiles from 0 up to 5. And you can see these are different images containing different sprites in a sprite sheet. I'm gonna take the first one, so tile set 0, this one right here. And you can see here we have trees, we have bushes, we have blocks, we have more trees, more bushes, we have grounds. And this is what we want here. This ground, this part right here is exactly what we want. Now, since this is a sprite sheet, because we talked about sprite sheets, we need to set the sprite mode from single to multiple. And let's go down here, hit apply. So now I am gonna open sprite editor and we can slice these. Remember when I first talked about slicing and I said that Unity can slice things on its own, and sometimes it can't? Well, in 99% of the times, Unity knows how to slice things correctly. But for example here, since you see this right here is practically one image, if we try to slice it automatically, so if I go here, click slice, bam, you see how we have it? All of this right here, you see this ground and this other ground and this ground lower and this right here, all of this is sliced in one. We don't want that. Now this tree is sliced on its own, which is good. This right here, all of these blocks, you see all of these blocks, we have 7 of them, they are sliced as one. We do not want that. How can we fix it? Well, we need to do this manually on our own. So if you want every single individual part of this or these blocks, you will need to resize this by dragging it like this and resizing it and again like this. And now only this single box, this one at the bottom left corner, is sliced. And now click here and drag with your mouse, and then you have a new rectangle here that will be represented with the slicing. So if I go here and resize it again, so now we have this second block here that is, well, also now sliced. And we can reuse it as a separate block. But we don't want to do all of this because we don't need this right now. What we need is this part right here. So I'm gonna only slice this part manually on my own. Simply resizing, so clicking left mouse, so holding your left mouse button, click on it and then resize it. And simply then, well, where you think it's okay for you to, well, resize this block. So let me just go something like this. I think it will do. Maybe something here and here. And I think we are okay. I think this is okay. Maybe on the top, just a little bit lower. And bam, this is it. If I hit apply now and go outside here and select, click on the drop down list, we have this tile, which is, well, a single tile, and this is what we want. Let me just rename it to ground. I just wanted to represent it visually, as I already said, and we have learned how we can slice things on our own if Unity's automatic slice does not work for us. Now we can take this block right here, this ground, and we can click on add component, which is in the inspector panel right here on my right side. So when you select something in the hierarchy panel, so when you select it, you will see its properties in the inspector panel. You will see all components that are attached on that game object. And here we see that we have the sprite render because, well, we have this image. And when we click on add component here, we can filter for components that we can add to our game object. We need a box collider 2D. Now, please, 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 please bookmark this. Don't confuse box collider, which is the first one, with box collider 2D. Box collider, the first one, is for 3D games. If you add the box collider, which is for 3D games, on a 2D object and you try to use 2D code on it, it will not work. We will see more examples, but I'm just telling you to pay attention when you add the Box Collider 2D. Make sure it is actually a Box Collider 2D and not only a Box Collider. So Box Collider 2D, and what is a collider? Well, that will help us detect collision between game objects, which we will see in a second. I'm gonna just lower this ground a little bit down and rescale it. How can I rescale it? Well, you have the scale on the X right here, as you can see in the hierarchy or in the inspector panel. So you can rescale it on the X like this. This is just so that we have a ground to stand on. Don't worry, we will fix this later on and create our new ground. So don't worry about that. Or we can simply click on this tool, which is at the top left corner. So you see we have 1, 2, 3, 4, 5 tools. So we have the hand, we have these arrows, we have this one, this is for rotation. I don't know how every single individual tool here is called, but well, this is for rotation. This one is also, I think, for scaling. Yeah, this one is for scaling. And we have this one right here that is also allowing us to scale things. But as you see, we scale it like this. So yeah. Anyways, you can scale it on these or this many ways. So either here in the scale, in the inspector, or actually, yeah, in the inspector panel, or using this tool, this right here, the last one, or the before last one, which is actually for the scale, as you can see right here. So how can we actually now preview that collision between game objects? Well, for that, we need to add to our player a Box Collider and select the player. Go under Add Component, filter for Box Collider 2D, and bam, here it is. Now, as you can see how this is on the player, I don't want this Box Collider to circle the player like this all his width. Instead, I want to resize it a little bit on the X, just so it is smaller. Something like this will do. Yeah, this is okay. Just resize it here in the Box Collider property, so you have the size on the X and on the Y, so you can move it left, right, up and down, or actually left and right for both of these, not up and down. I was like, Y-axis is up and down, but no, it's left and right. So on the left, you resize it or shrink it. On the X, on the right, when you scale it up. Or you can simply use numbers. So 0.38 is for the width of our X size for the Box Collider. Now, if I run the game now, nothing will happen. You see, nothing happens and bam, why is that? Well, because we don't have gravity affecting our player. In order to have gravity, we need to add something called a rigid body. So click on Add Component, filter for rigid body, and we have rigid body and we have rigid body 2D. Same thing as with Box Collider and Box Collider 2D. Rigid body is for 3D game objects. Rigid body 2D is for 2D game objects. So please, when you are working with 2D games and you want to add 2D physics, add a rigid body 2D. So yeah, here it is. So we have now a rigid body 2D that will make our player have gravity. So if I hit the play button now, bam, you see the player fell down and he is standing on the ground. That is because we have a collider applied on the ground. If I remove the collider, actually I'm not gonna remove it, but I'm just gonna uncheck this checkbox right here next to the Box Collider 2D name, which will make it not active. It is on that game object, it is attached, but when you uncheck this checkbox, it will treat it like it is not there. So it will treat it like it's not active, it's not there. And notice what's gonna happen now. When I hit the play button, well, where did our player go? What's happening? Well, it's happening that our ground does not have a Box Collider. It does, but it's not active, so it's not there. And the player does not have anywhere to stand on. So these are colliders. Colliders are used for two game objects to have collision between them, so they can stand on each other. We can then detect in our code when one box or when one game object touches another game object, so on and so forth. So if I hit the play button again, now that I have set the Box Collider on the ground to be active again, bam, we have collision between them. So what is the next thing that we want to do? The next thing that we want to do is right-click, create a new folder called Scripts. Inside of the Scripts folder, right-click again, create a new folder, which we are going to call Player Scripts. And inside of our player scripts folder, right click, create a new folder. Just kidding, but we are going to create a new C# script and we are going to call it player movement. So we are going to call it player movement. If I drag and drop this on the player like this, so simply drag and drop it, bam, we see that this script now is attached on our player, and this is how scripts get executed on game objects. You attach them as components. You can also go here under add component and filter for player movement, and bam, here it is, because it's a component. It is treated as a component that you can attach on a game object and have it on it. So now, double click it and open it right here in MonoDevelop. Let me just hold enter here. So tag it with the class and hold enter just to give a little bit of space. This is something I do every single time because I like to have this scroll down, up and down, so it can be better for your visual perspective. So you can see better. I can move down when I'm typing some code. This is why I'm holding enter. I tag the class here with this tag so that I know where this last curly or closing bracket for the class is, because it can happen that I do something like this, void, I don't know, my move, and I do something like this. I don't close it. You see, I don't close it. Then we have a problem. So if we go back here in Unity, you see here it says unexpected symbol and the file, things like this. And then I can go and I can see, okay, what did I miss? If I click on this one, so if I click here on this curly bracket, I see that it is pointing to this curly bracket, but this is not the closing curly bracket for this function. It is the closing curly bracket for the class because I have tagged it here as a class. So I know that I've missed here a closing curly bracket. And this is why I like to tag the class here at the bottom. So moving forward, what do we need for our player movement? For the player movement, we need speed. So public float. What is this? Float speed, which is going to be equal to 5f. We also need a rigid body that we have attached because we're going to use rigid body in physics to move the player. So we're going to say here private rigid body 2D, and I'm going to call it my body. And we need a private animator, which I'm going to call anim, because we want to animate our player moving. What do we do next? Well, these are components attached on our game object. We need a reference to them. In our C# section, we talked about objects and references to those objects. This is the same thing. This right here is an object. We need a reference to it. And how can we get that reference? Well, we're going to do that in void awake function. This is inherited. Start and awake and update. This is inherited from mono behavior. We talked about that in our C# section. So we talked about inheritance. Awake function is the first function that's called when we run our game. And for that, I'm going to say here print, and I'm going to say called first. And here in the start, I'm going to say called second. And you're going to see this, what I'm talking about. So if I go back here, clear the console, if I hit the play button, you will see called first is printed, which is from the awake, and then called second is printed, which is from the start. That means the first function that is called when we run the game awake. So this is the first function. Next is on enable. We will talk about that later on in the course. And we also have start. So first is void awake, then we have on enable, which is, well, similar. We can initialize things here, and then start. Usually you will use awake and start for initialization. What I like to do is in the awake function, I like to get references to these components. So my body, or the rigid body, is attached on the player game object. And for that we have a function so we can get components from ourselves, so from the game object where that component is attached. So I can say my body is equal to get component and pass here rigid body. You see, open close these less than sign and then greater than sign, and between that type rigid body. This will denote which component we want to get. So get us the component that is attached on a game object who carries this script. And which game object carries this script? Well, it's the player himself. You see, player has the player movement script, this game object right here, which also has a rigid body right here, which also has a box collider. All of these are components. And inside of our code, we can type get component. And now we need to specify here which component we want to get. Well, we want to get a rigid body 2D. Same thing with the animator. Animator is also a component, as you can see here. So let me just scroll up. You see the animator right here? He is a component attached on our game object. What does that mean? That means that we can say anim is equal to get component less than sign, animator greater than sign, and it will denote that we want to get our animator component. So what do we need to do next? We need to create a function that will move the player. We are going to do that below our update, and I'm going to call this one void player walk, and we are going to call this function in void fixed update. What is update? What is fixed update? You see, update right here is called every frame in a second. If we have 60 frames in a second, it will be called 60 times. Fixed update is called in number intervals. So it will be called in fixed time step. What does that mean? That means that it will be called every 2 or 3 or 4 frames. We can edit that right here. So we can go under edit, and we can go under project settings, and we can go under time, and we have this fixed time step, which is 0.02. That means every 0.02 of a second, this function or fixed update will be called. Now, usually you're gonna leave it like this right here. This means that every 2 or 3 frames, this fixed update will be called. So it will not be called as often as update function. So if update function will be called 60 times in a second, this one will be called, let's say, for example, 20 times. And this is where you put your code for physics. So if you want to use any physics calculation, do some rigid body code, you do it in the fixed update. Of course, sometimes you will do it in the update itself, but most of the times you will do it in the fixed update. So here we're going to call our player walk function, which is this one right here. And now we are going to get the input from our player. So here we're going to say float h, which is short for horizontal, is going to be equal to input get axis, so get axis raw, and it's going to get us the horizontal axis. What does this mean? This means that we will know when we press the A key or the D key, left arrow key or right arrow key. Horizontal axis, left, right, we will know it. And what does this raw mean? Well, it means the following. So if I go here and I say print h, and I will say value is, and I'm going to say plus h, which is, well, this one right here, you will see that if I go here, clear the console, hit the play button, notice now currently we are printing 0. If I press the D key, we are printing 1 because 1 is the positive, we are going to the positive side. If I press the right arrow, we are also printing 1. If I press the left arrow, we are printing -1. If I press A key, we are printing -1. Why? Well, because left side is the negative side, right side is the positive side. So this raw means whole number because we also have get axis like this, which means the following. So if I go here, clear it, and if I hit the play button, if I press the D key, you see, let me just go back here upwards, you see how we are getting this value. So it goes from, let me just go back here, come on. Yeah, we are going from 0, then 0.07, 0.15, 0.25, 0.3, 0.4, up to 1. So when it's only get axis like this, we are going from 0, then in decimals, up to 1. But when it's get axis raw, we will go directly from 0 up to 1 or -1. So this is the difference. And what we are going to do now? Well, we are going to use this h and we are going to test if our h is greater than 0. What does that mean? What did I say a moment ago? I said that the right side is the positive side. So if h is greater than 0, that means that we are going to the right side, which is the positive side. So we're going to move our game object to the right. And for that, we're going to say my body dot velocity is equal to new vector 2 And vector 2 is an object that contains x and y. So first parameter is for the x, which is going to be the speed. Second parameter is the y, which is going to be speed on the y-axis, vertical speed. For that, we're simply going to say my body velocity dot y, because we don't want to edit velocity y. We only want to edit velocity x. Move the game object to the right or to the left. So this is if the age is greater than 0. Else, if our age is less than 0, that means we are going to the negative side, which means that we can simply copy this code, paste it right here, and simply here set the negative speed, which will move our game object to the negative side. So we can test it out now and see if it actually works. So if I hit the play button, clear the console, and right now, if I press the right key, you see we are going to the right side. And what is wrong with our player? Is he drunk? Awesome runner or awesome platformer. Are you drunk? What is wrong with you? Man, I know I shouldn't let him go out. What is the problem here? Well, the problem is that we need to go inside of our player. So select the player. And for his rigid body component right here, you have these constraints right here at the bottom of the rigid body 2D component. Click on constraints, and we need to freeze the Z rotation, which will prevent him from falling down. So the Z rotation, or freezing it, it will prevent him from falling down. If I run the game now and move him right, you see he's moving right. Moving him left, he is moving left. Voila, you see left, right, left. Right now we cannot jump because we did not program that, or move up and down because we did not program that also. But you see here, going left, going right, going left, going right. And also notice, if I hold right and release it, he's like sliding a little bit, like he is on some ice. And also for the left, I release it, he is sliding. So this is how we can move our player, and we will fix the sliding thing and the animation thing and his facing. We also want the player to face the right side when he goes to the right, but we also want him to face the left side when he goes to the left. He's not like walking backwards. Nobody walks backwards like this, except, well, maybe I when I'm drunk or something like that, but no. Anyways, this is it for this video. We are already too long in the video because we explained so many things. And by the way, this velocity is speed over time. So we are editing velocity right away, applying directly speed to the velocity, so our player starts moving right away with the rigid body. And we apply velocity by using a vector 2 because this is a 2D game. We have X and Y. It's not a 3D game where we also have Z, so we can apply speed on the Z axis, but we have X and Y. So vector 2, and I'm explaining this because people get confused. What is vector 2? What is vector 3? Vector 2 is X and Y. Vector 3 is X, Y, and Z. Simple as that. So the first parameter is X. Second parameter is y. And why negative speed right here? Well, because we are moving to the left side. Remember, left side is the negative side. So we need to add the negative speed in order to move our player to the negative or left side. In the next video, we will animate our player while he is moving. We will also fix that facing direction, and we will talk about prefabs. Until then, Fahir here from AwesomeTuts.com. I will see you guys in the next video.